Hello everyone, welcome back. In this video, we'll look at how to submit and monitor our jobs on the HPC using QSub. So let's first look at how to do it using a shell script. For this, we'll need to create a file. I've already created mine and named it pbs.script.sh, and here's how it looks like. This script simply loads Anaconda and runs a Python program that uses PyTorch to train a simple MS classifier. We start the file with the header hashtag !bin/bash to tell the compiler that this is a bash script and needs to be executed. Following this, we have a couple of pbs commands. So we start with hashtag pbs-n starter to tell the batch scheduler that we would like to name our job as starter. You can pick any name for your job and write down with the flag -n to name your jobs. Following this, we have the flags -o and -e to tell the batch scheduler that any output given out by a job should be written to the file out.log, and any errors that are given out by a job should be placed in the file err.log. Following this, we use the flag -l to request for resources from the batch scheduler for our job. We request for 20 cores using the variable n CPUs, and we request for a total compute time of 10 minutes using the variable wall time. Following this, we list out the commands that we would generally write on our terminal in that same order in order to execute the program. We first load Python using the command module load compiler /anaconda3, and then run the file pytorch mnist.py. Let's look at this file. So as you can see, this is a very basic PyTorch program that would train a simple classifier on the MNIST dataset. One thing to note here, that on the HPC only the master node has infinite connectivity, and since our jobs are executed on compute nodes, if you were to write your program such that it downloads files on the go, your programs would not execute. So in order to avoid that, you would first have to download your data sets on the master node and set your paths accordingly so that the compute nodes can access it. So here I've placed my files in the folder data on the master node and set my paths accordingly. Let's go ahead and run this file. To run a particular script, we use the command qsub -q to enable a queue, and we will write CPU to tell the scheduler that this is a CPU job, and then we write out the script's name. And now our job is submitted and we are given out a job ID. So the previous two commands, qstat is used to look at all the jobs that are currently running on the HPC. Here we can see that our job is also running with other jobs. Much definitive command to look at the details of our job is qstat -f followed by the job ID returned by the qsub command. So here you can see that the amount of memory being used by the job, along with the information that our job is running on compute 9 and has been allocated 20 course, and various other informations. Now let's take a look again. So job is finished, and we can take a look at the output and the error files. So here we have that the program has executed, and all the output has been written to this file. Now let's take a look at the error file. Here we just have a warning from Anaconda that we are not using CUDA, which is pretty obvious because we submitted our job on a CPU node. If you were to submit a job on a GPU node, we will just need to change -q CPU to -q GPU, followed by a script name, and we are very similarly given back a job ID. Our job is running, and you can see that on the queue it's mentioned that we have a GPU job running. Let's take a look again. We'll have to wait a couple seconds for the job to finish up. Okay, so our job has finished, and we can now go and take a look at the error file, which is empty, and we have the same output in our output file. So that brings us to the end of how to submit a job using a shell script. There are a few other PBS commands that can be used for much complex tasks. You can look at those information at our HPC's website. And let's move on ahead to taking a look at how to use the QSub interactive mode. So this is something that you would use when you require a little more resource than what your laptop or your workstation has in order to prototype your job before actually submitting it using a shell script. To request for an interactive shell, we would write qsub-i-q. For a CPU shell, we would write -q CPU, and we are returned a job ID along with a shell. We can take a look here at the terminal header, which has changed to compute1 instead of master, which tells us that anything that we execute now will be executed on compute nodes. So let's go ahead and actually run the previous program again. So we'll have to first load modules, and run the program. So we get the same warning, and our program will soon start to execute. So our program has finished executing, and we can do this very similar thing by requesting a GPU node just by the command qsub-i-q GPU. Here take a look that our header has changed to compute 3, which is actually compute node with GPUs, and we will again have to load compilers and execute the program. So that brings us to the end of executing our task. Now we can go back to our master node. So this concludes our tutorial on how to use the HPC to submit jobs and monitor them. You can find any other information regarding the HPC on our website at hpc.ashoka.edu.in. Thank you.